In last video I have discussed about problems of NCERT book exercise 6.1. Now this is question number 14 of NCERT book. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. That is, the volume of the cone is increasing at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. Full stop. How fast is the height of the cone increasing when the height is 4 centimeter? Now we are given that this is your cone that is formed by the falling sand. The volume of the cone is increasing at the rate of 12 centimeter cube per second. You are also given that the height of the cone is always 1/6 of its radius, that is h is equal to 1/6 of r. So I am getting r is equal to 6 times h. We are also given that at any instant when the height is equal to 4 centimeter, that is your h is equal to 4 centimeter, you need to find the rate of increase of its height. So this is a cone. We know for a cone the volume of the cone is equal to 1 by 3 pi r square into h. So this is 1 by 3 into pi. The value of r in terms of h will be 6h. So I will place 6h whole square into h. After calculation you will get 12 pi h cube. This is your volume in terms of h. Now if I find dv by dt, because we need to find dh by dt, this is your unknown, you need to find this, the rate of change of height with respect to time. So finding dv dt, this is 12 pi, which is constant. For h cube, if I differentiate respect to t, I will get 3h square, but it is h, so I will write dh by dt. Now place the values. This is your 12 pi. The value of h is 4, so it is 4 square dh by dt. 12 cancel, hence the value of dh by dt will be is equal to, after calculation, this is 16 into 3, 48 into pi, 1 by 48 pi centimeter per second. This is the rate at which the height of the cone is increasing. Now we will discuss some extra problems of other books. Number 1. A particle moving along a straight line is at a distance S from a fixed point O on the line in time t, where s is equal to t cube minus 6t square plus 8t plus 5. Find the velocity of the particle when the acceleration is 12 centimeter per second square. So you're given that the displacement s of the particle is given by s is equal to t cube minus 6t square plus 8t plus 5. We know when I differentiate s respect to t, that is a ds by dt, this is my velocity. So if I differentiate s respect to t, I'll get 3t square minus 12t plus 8. This is my velocity. And if I again differentiate, that is d2s dt2, this is my acceleration, right? This is 6t minus 12. Keep in mind ds by dt is equal to velocity, and if I differentiate v respect to t, I will get acceleration, right? This is your acceleration. Now you are given that according to question, find the velocity when the acceleration is 12 centimeter per second square. So given that a is equal to 12, a means 6t minus 12 is equal to 12. So I am getting 6t is equal to 24. So after cancellation, I get t is equal to 4 seconds. So the time is 4 seconds. Now we need to find the velocity when the time is 4 seconds. So now when t is equal to 4 second, your velocity v is equal to, put the value of t equal to 4 here, it is 3 into 4 square minus 12 into 4 plus 8. So this is 48 minus 48 plus 8. So it is 8 centimeter per second. This is the velocity of the particle when the time is 4 second. Now question number 2. For a particle moving along a straight line, the relation between the velocity and the displacement at any instant is given by v square is equal to x cube plus 2x square plus 3. Keep in mind v is your velocity and x is your displacement. So whenever I will differentiate x respect to t, I will get the velocity. Now find the acceleration of the particle when it is at a distance of 4 meter from a fixed point on the line. So remember that dx by dt is nothing but velocity. Okay, you need to remember this. So given that v square is equal to x cube plus 2x square plus 3. Now if I differentiate respect to t, I will get for v squared it is twice v, and for v it is dv by dt. What is d by dt? dv by dt is nothing but your acceleration, right? So you must remember these things. It's very important. For x cube it is 3x square. For 2x square it is 4x. For 3 it is 0. But this is function of x. So I'll write dx by dt. Now we are differentiating respect to t. So I must mention this. So what is this 2v into dv by dt? This is my acceleration. 3x square plus 4x. What is your dx by dt? This is your velocity. So v cancelled. So I'm getting dv by dt is equal to 3x square plus 4x by 2. You are given when x equal to 4 meter, at the instant when x equal to 4 meter, the displacement of the particle is 4 meter. Your dv by dt, this is your acceleration, is equal to 3 into 4 square plus 4 into 4 by 2, that is 32. This is 48 plus 16, 64 by 2, 32 centimeter per second square. These are simple problems of kinematics. Now it is time to solve question number 3. The distance x centimeter traversed by a particle along a straight line in time t seconds is given by x equal to 2t cube minus 15t square plus 36t plus 6. At what time will the velocity of the particle be minimum? See, now it's given that it's velocity. If it is speed, then we could have said it is minimum when it is 0. But in case of velocity, it can be minimum when it is negative also. Okay, so you are given that the distance x traversed by the particle along a straight line is time t is given by x equal to this. So this is x equal to 2t cube minus 15t square plus 36t plus 6. Now if I differentiate x respect to t, I'll get dx by dt. This is your velocity. This is 6t square minus 30t plus 36. So after taking 6 common, I'll get t square minus 5t plus 6. See, we need to find its minimum value. We need to find its minimum value. So this is 6. Now I can write t square minus 2 into t into 5 by 2 plus 25 by 4 plus 6 minus 25 by 4. I'm trying to make a perfect square here. Okay, so after that I'm getting this is t minus 5 by 2 whole square minus of 1 by 4. So clearly this is a quadratic expression. This is a whole square plus minus 1 by 4. When it is 0, the value will be minimum. So I can say that dx by dt is minimum when t minus 5 by 2 is equal to 0, that is your t is equal to 5 by 2 seconds. So when t is equal to 5 by 2 seconds, the value will be minimum. As this is 0, it is, see, this is whole square, so always it is positive. So positive minus 1 by 4. So when the quantity will be 0, it is minimum. Otherwise it will always, value will always increasing. So we can say that dx by dt is minimum when t minus 5 by 2 is equal to 0. So the time is equal to 5 by 2 seconds, that is 2.5 seconds. Now it is question number 4. This is a very good question. It is given that a boy 1.8 meter tall walks straight away from a lamp post of 9 meter height at the rate of 2 meter per second. How fast is his shadow lengthening? See, now there are two things. The height of the lamp post and the boy are, we have to see, these two things are not equal, right? This is 9 meter, this is your height of the lamp post, and this is the boy, this is 1.8 meter tall. Now when light falls on the boy, it casts its shadow. This is your length of the shadow, y. This is x, the distance of the boy from the lamp post at any time or any instant. We need to find, you are given that dx by dt is equal to 2 meter per second. This is the rate at which the boy is walking away from the lamp post, and this is your y is the length of the shadow. So we need to find the value of dy by dt. How fast is his shadow lengthening? So let x be the distance of the boy from the lamp post and y be the length of his shadow. Now we can use geometry. These two triangles, if I name them A, B, C, and this is D, E. Now from figure, triangle ABC is similar to triangle DEC. So I can say that AB by D is equal to BC by EC. So clearly this is 9 by 1.8. BC is equal to x plus y and EC is equal to y. Now what is this? If I divide by 1.8, it is 5. So clearly 5y is equal to x plus y. So 4y is equal to x. So if I differentiate, I'll get dy by dt is equal to 1/4 of dx by dt. Now put the values. 1 by 4 into 2, this is 0.5 meter per second. It is the rate at which the length of his shadow increasing. This is a simple geometrical problem. Now question number 5. Two stones are thrown vertically upwards simultaneously and their position at the end of time t seconds is given by s is equal to 19.6 into t minus 4.9 t square and s is equal to 9.t minus 4.9 t square respectively. Show that the second stone return to the point of projection when the first stone reaches the maximum height. See, here they have used the formula of s equal to ut plus half at square. When you will throw the stone vertically upward, g will be negative. So it is, in place of g they have place of a they have used g. G means 9.8. And so it is, for the first stone, its position from the ground at any instant is given by 19.6 t minus 4.9 t square. This is for the first stone. Now the first stone is thrown from the ground. It reaches the maximum height and then it returns to the ground again. So S is equal to 19.6 t minus 4.9 t square. When the stone will reach the maximum height, at this point its velocity ds by dt will be is equal to 0. That is why it will again come down. If the velocity is 0, then it will reach the maximum height and then it will again fall. So ds by dt, this is equal to 19.6 minus 40 squared is twice t. This is 9.8 t. At the maximum height, ds by dt will be is equal to 0. So 19.6 minus 9.8 t is equal to 0. Clearly, if I solve, t is equal to 2 seconds. So after 2 seconds, the first stone will reach the maximum height. Now, for the second stone, you are given that the second stone reaches the point of projection. See, if the second stone is thrown vertically upward and it again reaches the same position here, so total displacement will be is equal to 0. So given that S is equal to 9.8 t minus 4.9 t square, when the stone reaches the point of projection, your total displacement will be is equal to 0. S is equal to 0. No vertical displacement. So it is 9.8 into t minus 4.9 t square. Clearly, if you solve, you can take common t. You can take common 4.9 t. This is 2 minus t is equal to 0. So t can never be is equal to 0. So t is equal to 2 seconds. Clearly, both the first stone reaches the maximum height after 2 seconds and the second stone will reach the point of projection after 2 seconds. So question is solved.